Well, hi everybody, it's Tim here. So on my bench, and you've probably seen it over here in the corner here, normally in its regular position, is my TS-940. I've had it for quite a few years. Bought it used, of course. It found me. Probably paid a little too much for it. But anyhow, I did a couple mods to it. Not recently. I was actually just working on something that I'm going to bring up here in a few minutes. But figured I'd show you some of the stuff that's been done to it. Let me turn the volume down here so you can continue to hear me. I'll turn the lights off so you can see. I put the LEDs behind the meters and back behind the display here, and that seemed it was a nice, easy thing to do. What else did I do? I'm going to turn the lights back on now. Watch your feet. I got the doggy here. Okay, so when I got it, it had these two extra filters here, this one and this one, and I guess they were generic filters because this is the way it came. But I'm told they're pretty good filters. But anyhow, trying to zoom in a little bit so you can see them. They actually, instead of sliding over the pins, you had to actually solder them onto the pins. I wouldn't go out and buy them and do that, but you know, that's the way they came, and so be that. What else? When I got it, it had very, very low output on all bands. So one of the things I found too, it had very, very weak receive at times. And right here, pointing to, I'll zoom in there so you can see them. I'm going to unplug it so that I don't stick my fingers in there. There we go. Where are they? Let's see, right here. And I'll zoom in so you can see them better. There's two relays here, and they control the attenuation. It's these two guys right here, I believe. And the attenuator didn't work correctly. You know, and you can tell if you turn yours on and it sounds better at you know, maybe 20 dB than it does at 0. But anyhow, sometimes I know I've seen, and I think Buddy over at the radio shop, he did one where the resistors down in here actually burned up, possibly due to a lightning strike or some kind of RF feedback. On the case with this one was these relays were just so disgustingly dirty inside that all I did was I used some what's it, the contact cleaner, you know, soaked down a piece of paper and slid it. You take the relays out, take them apart, and slid it between the contacts on both the rest and the energized side, because I believe these, when you turn them on, they energize when you first turn the radio on with no attenuation. It's when you turn it that they turn off the other way. So anyhow, you want to make sure you clean both sides of that. They're real easy. This board's really easy to get out. Again, with most of these, the things have been together so long, if it's not labeled, that's why I post a lot of pictures and take a lot of pictures. If it's not labeled, the connectors almost kind of fall into place where they should go. You might get things like this that all kind of look the same, that you may be questioning. So that's it with that. Let's see, what else did we do? I did a couple of things to it. It didn't. The main thing you're going to find on these is loose connectors. That's what's going to happen with a lot of these. Now, I did find on this is the RF board, and I did find some bad solder joints on the RF board, and that was actually limiting my output. So in testing, and I had a little bit of bad luck with testing. Somehow or other, I slipped back at the RF board and I fried the 28 volt power supply, which in turn took out the drivers. So There's a fellow on eBay that sells a kit to convert those drivers to an available 12-volt driver. So I did that, and it still works great. I'll show you that in a minute. I had to rebuild the power supply and basically fix the part of the board that I fried. But I'll show you what I did. So here is where the modification lies for the board. So generally what happens is you take the two driver transistors and you convert these both to transistors that are 12-volt transistors as opposed to the 24 or 28-volt transistors that are in there. So because it's almost impossible to find these drivers. And if you do, I think you can still get them through that Kenwood distributor for about $35 a piece. Now there was a fella from China that sent me some to try, but they went into oscillation, self-oscillation. I'm imagining that's what happened, and they blew themselves up within just a couple seconds of setting the bias. So anyhow, with this kit, he sends you the whole kit. He sends you everything, the whole kit and caboodle. Right here is, I'm going to zoom down so you can see where my finger is pointing, and I'll show you. I'll zoom in the other end where I'm actually getting closer. So that is a 12-volt relay, or a 12-volt, not relay, regulator, I'm sorry. And what you do is you go back up here to where you can see I have this little standoff mounted. Right here is normally where the 28 volts enter the board to go to the finals and the drivers. So what we do is the voltage that's going to go to the drivers, you just pull this coil up here and you can do whatever. They don't give you a standoff, but this is a vacuum tube or a point-to-point standoff. I mounted that there and I made my connections. So basically you still have the 28 volts coming into the regulator, then back out, going in, and now these two drivers are 12 volt. I still have no problem getting 100 watts at least out on all bands. Yeah, so far it's worked pretty well. I have no issues with it at all, and it was relatively cheap. I think it was probably about shipped from I forget where the fellow lives, maybe England. It was $34 or something. And the reason I went with what he described was because he actually matched what he claims to of it, and it seems to be pretty close to matched as far as when I'm setting the bias, but for the two drivers. And like I said, he gives you the whole kit, so I figured I'd give it a try. I put it in, works great. This comes out relatively easy. There's 3 screws that you can take out that are on the, you get them from the inside. There's one here, and then one right down the center that you get. This will all come out, and you can drill it and mount your regulator just like I did there. Don't forget a little bit of conductive grease behind it, but to tell you the truth, that doesn't even get that hot. So let's see, what else? Oh, and then I used silicone wires, and they don't like to hold the shape like solid wire does or anything else. So I use these are just little little conduits. I cut little pieces of conduit and I clipped it on the board. That way I didn't have to drill holes anywhere or anything, and it keeps the wire out of the way when you put the cover on. Again, it's been like that for a couple years, no issues so far. So the main thing I'm working at with it right now is have the S meter issues with it. And what's kind of weird is, and I'm going to pause this while I turn it around and plug an antenna in so I can show you. Alrighty, let me back out a little bit. I'm going to zoom down here to the meter here in a little bit. I don't know how much you can see there. There we go. So the meter, and I'll turn, maybe if I turn the lights off you can see it better. Oh yeah, that looks just lovely. I really can't see how it looks. I was being facetious. I'll turn this back on. Okay, anyhow, we'll find somebody that I can tune to. Oh, as you can see, the meter seems to be moving. Somebody talking. It's a very low noise level right now. That's on 3.9. So we'll go up 7.4. Meter's still pretty responsive. We go. Once I get to 8 or 14. Once I get to 14, the meter drops off. Now, if there's a powerful signal, it'll still move. But basically, it works like that all the way through. As you see, very little movement. So first thing I thought was part of the filter system for the 14 through etc. was not working correctly. So these are pretty neat how these work. Here's the filter systems back here. This one does from 20 to 30 megahertz, these three. This one does from 14 to 20 megahertz. Let me see if I can do that again so you can see what I'm talking about. All right there. Anyhow, right here, these are the 20 to 30 megahertz filters. These are the 14 through 20 megahertz filters. And then it goes, as you go up, these other filters come into play. And you can see these little diodes here at the top and maybe not so much at the bottom, but they use the diodes as switching. So what happens is when you choose a certain band, or when the radio is tuned to a certain band, it applies a voltage to the diode, basically to let the current start to flow through the diode. And the RF rides on that signal, and then that's how it gets routed through. That's how the switching diodes work like that. So if you look at it, you can get a voltmeter basically and check through all these and see which ones aren't conducting. It'll all be at, say, 13 volts. Those ones that are not conducting. And then when you get to the one that dropped down to just 3, 4 volts, whatever it is, and the manual tells you actually what voltage you're looking at. Then that's the filter that's active at the time. So now by checking this, I was able to just make sure that all the filters are acting the way they're supposed to, and so be it. So I put a minus 73 dB, which should be an S9 signal in, and I get S9 all the way through, except on like 28 megahertz I'm getting well over S9, but yet the meter's still really sluggish. So I went through the calibration of the meter again, and it's not really helpful. And if you've ever done any of the alignment on this radio, the alignment is actually kind of scary. There's a lot of things in there that I think to myself, there has to be a better way to do that. And there's a lot of errors in the manual itself. So you don't want to go ahead and start screwing around and turning things without having a really good reason to do so. But anyhow, so the next thing I want to do is investigate why the S meter is not working, and if anybody, again, like I said, it works, but it's very sluggish on 14 megahertz and up. So just trying to think a lot of those things through, get my head wrapped around it. But if any of you have ever seen that issue or remedied that, feel free to put something in the comments. I know that I've read a couple places where people tell you that on the IF board there's some resistors that need changed, that they were in the wrong spot, and there was a lot of going back and forth about that. Yes, they were, no, they weren't. I'm not really big on changing what the factory built. And some people are saying the capacitors are faulty, which that could be the case too. But the only problem is by the time it gets down to the IF board, it's already started to go through some mixing processes. So the frequencies, I think it's around 45 megahertz once it gets into this board. I don't know why there wouldn't be such a frequency difference between 28, say, and 3.5 at that point, because it's using the mixing. But I haven't really looked too far into it, so maybe that's the case. I don't know. I'm going to look into it and find out. I'll do a little bit more research and hopefully find something out. But in general, like I said, it works okay. The meter's just sluggish. So thanks for watching. That's all I got for now with the TS-940. Nice radio, old radio.